Finding the limit of a single function is easy. But what if you're taking a more complex limit, like the limit of a composite function? In this video, I'll show you exactly how to handle limits of products, quotients, and composite functions, each step by step. It's not actually that bad once you know what you're looking for, so let's dive right in. In this example here, we have a product of functions. Let's approach this just like we're approaching any other limit. First, let's find the limit from the left. To find the limit of a product of functions, we can just find the limits separately and then multiply at the end. So the limit of f of x as x approaches 0 from the left is 1. The limit of h of x as x approaches 0 from the left is 4. The product of 1 and 4 is 4. So the limit of f of x times h of x from the left is 4. Now from the right, the limit of f of x as x approaches 0 is 1. The limit as h of x approaches 0 from the right is 4. The product is 4 again. Since the one-sided limits match, the limit of f of x times h of x as x approaches 0 is 4. Let's look at another example. What is the limit of f of x times h of x as x approaches 1? First, let's find the limit from the left. The limit of f of x as x approaches 1 from the left is 0. The limit of h of x as x approaches 1 is 4. 0 times 4 is 0. So the limit from the left is 0. Now on the right. The limit of f of x as x approaches 1 from the right is 0. And the limit of h of x as x approaches 1 from the right is also 0. So the limit of f of x times h of x from the right is 0 times 0, or 0. Both of our one-sided limits are 0, so the limit of f of x times h of x as x approaches 1 is 0. So that's the limit of the product of functions. The limit of the quotient of functions is very similar. Just like the product of functions, we first need to take the one-sided limits of the individual functions and then piece it together. If the limits exist, so does the limit of the quotient. Well, most of the time. There is one caveat. What value can the limit of the denominator not be? 0. If the bottom is 0, then sometimes we'll get an undefined limit, so we'll have to keep an eye out for that. Alright, now let's see the limit of the quotient of functions at work. What is the limit as x approaches 0 of f of x over g of x? First, we know that we must take the one-sided limits. Starting from the left, the limit of f of x as x approaches 0 is 1. The limit of g of x from the left is also 1. So the limit of f of x over g of x from the left is 1 over 1, or 1. So far, so good. Now, what are the limits from the right? Well, the limit of f of x as x approaches 0 from the right is 3. The limit of g of x from the right is also 3. Once again, 3 over 3 is 1. The one-sided limits of f of x over g of x are both 1, so 1 is the overall limit. Here's another example. Does this limit exist? Well, let's check. As g of x approaches 1 from the left, we see that it approaches 1. But the limit of h of x from the left is 0. 1 over 0 is undefined. So that means either this limit doesn't exist, or it's unbounded and approaches infinity. Now, when substituting, if we got something like 0 over 0, then that could also mean that the limit still exists. But we'll touch on this later, in another video. Now, let's look at the limits of composite functions. To calculate the limit of a composite function like f of g of x, first we need to evaluate the limit of the inner function as it approaches the given value. And then we need to find the value of the outer function at the value of the limit. However, for this to be the case, two things must be true. First, the limit of the inner function must exist. And second, the outer function must be continuous near the value of the limit. Let's try evaluating some limits of composite functions. What is the limit of f of h of x as x approaches 2? The first thing we need to do is find the limit of h of x as x approaches 2. Does this limit exist? Well, the limit of h of x as x approaches 2 from the left is 3. As x approaches 2 from the right, the limit of h of x is also 3. The two one-sided limits are the same, so the limit of h of x as x approaches 2 is 3. It exists. So now we need to check, is f of x continuous around 3? Well, using our pencil tracing technique, we see that we can draw f of x without lifting up our pencil, so it is continuous. Since the limit of the inner function exists and the outer function is continuous, we know that the limit of the composite function is the outer function's value at the limit of the inner function. F of 3 is 2, so the limit of f of h of x as x approaches 2 is 2. Finding the limits of the product of functions, the quotient of functions, or composite functions can be deceiving and seem like a lot, but just break it down. Take it on like you would any other limit, and you'll be solving them in no time. If you enjoyed this video, like, subscribe, and share it with a friend. Now, keep working hard and keep learning. Thank you for watching.